All right, folks, I am ready to get started here. Welcome back, everybody. Welcome back to the beginning of the fifth week together, the final week before the first exam. So I hope everybody's doing well. I hope everybody had a good long weekend. And by good, I mean you worked your butts off and you took every opportunity you could to cover as much material as you could for all your classes, because when you're in school, you are in school. No matter what is happening, that is the approach you have to be taking if you want to make all of this work out for yourself. You want to walk away feeling good about what you are doing here. Make this the priority. Um, so again, since we are closing on the first exam, I'll just quickly talk about it. Pretty standard. If you've seen the practice exams online, similar format, 6 to 8 questions with multiple parts, depending on what I've chosen. You're gonna have an hour and 10 minutes to do it. Some true and false, but mostly like open answer, like math-based questions that ask you to understand what we've done and be able to demonstrate that you can do it, and also understand what it is you are doing by being able to describe some of it in words, so you can tell me that you actually understand things versus just memorizing a bunch of stuff. So the exam, you won't need a Scantron, you won't need a blue book, you won't need any of that. I'll provide you everything you need, and the only thing you'll need is a calculator. So make sure you bring a calculator, scientific, not graphing. Graphing calculators can save information, and certainly not your phone, because your phone is not a calculator. It's a computer that can do a lot of things, including save an entire textbook. So no phones. Calculators, please. Yes.
On the graph calculator, you can clear the entire RAM so that everything that you have on it, all the data is cleared. So we showed you that we cleared that.
Nah, I just don't want to even deal with the complication. I have scientific calculators that I bring as well for people that don't bring one, but just try to bring one. But I understand where you're coming from, but still, I don't even want to deal with that. So, all right. Are there any questions about that? Yeah.
So the exam would be
Give or take. No, no. No, the exam you see online is an exam I would give. So it's a version of what I would give. So just assume some variation on that. Yeah. Other questions about that? I'll send an email today just to remind you guys stuff. And of course, I'll mention stuff on Thursday as well. So we have essentially covered 4 chapters thus far. We're going to cover one more chapter today, but we're going to go over consumer surplus really quick, which is something that was covered in chapter 5, which we don't cover. So I want to make sure I touch upon it because it's an important concept you should understand. So we'll just quickly talk about consumer surplus and how to calculate it. And then we'll get into chapter 6, the final chapter of the first section, in which overall in this first section we're dealing with the demand side of the market. We of course covered the basic principles in the first chapter, looked at some sort of general approaches that we take in economics when we're thinking about problems. We're doing marginal analysis. We're comparing the extra benefit to the extra cost of doing an extra thing. We're comparing total costs and benefits to decisions that are trying to address whether or not we should do something in general or not. So there's a few things in chapter 1 that are of course important that you should know. Then of course we covered the market model, which standard supply and demand. Anything we covered in that chapter is relevant and important to this entire course, so make sure you understand it. It gives you the basic intuition you need to basically understand what's happening in most markets, as things are changing and how that's affecting the outcome of the market. And then we got behind the demand curve and looked at the rational consumer choice model, which is a very specific model, but very powerful. So make sure you truly understand the workings of it, including the advanced math that you need to be able to solve the optimal consumption bundle problems. And then last chapter, we kind of branched off from that to a bunch of kind of related topics on the demand side, starting with the derivation of the individual demand from the rational consumer choice model to the market model. And then, we dealt with elasticities and a couple of other issues. So make sure you understand those things. Today, again, we're going to jump on consumer surplus, which is a measure of how efficient the market is being on the demand side of the market. So how are consumers benefiting from the market? Well, they get to pay a price that at least the ones that do get to transact in the market may undercut what they're willing to pay. So they have an excess willingness to pay, which is the consumer surplus, which we can quantify, which we will, and it has some meaning, basically telling us like how well consumers are benefiting from markets. When consumer surplus is being affected, then that is a signal that markets aren't working too well for on the side of consumers. Of course, there's a supplier producer surplus that we'll consider as well, but we'll talk about that later really quickly when we get into the second half of the course, which will take us through the end of the course, which will basically deal with all the supply issues, all the sort of the logic that goes into the supply decision, but that is going to range because there's different market settings we have to consider and how the market settings affect the decisions. In order to establish what the decision is, like we have to establish the nature of production and then extract the type of costs that a firm faces from that to then be able to compare benefits to costs. So it's a complicated system, and that's why it requires 2/3 of these types of courses generally to cover all possible cases and all intricacies of it. But the benefit of that is that there's a lot of connective tissue there for the next part of the course. So in this first part of the course, you're kind of jumping around small semi-related topics, but they're not as unified as you'll see in the second part of the course. Even the second part of the course will be more challenging because the supply decision is more complicated and requires a lot more insight and analysis. So that's where we're at. We're at the last part now of learning about the consumption side, and we're going to consider issues here of uncertainty. We've been assuming everybody knows everything, and we have all the information we need to make the decisions that need to be made that we analyze. But in this chapter, we're going to assume, well, what if you don't know everything? And what can we do with our approach to try to figure out like how prices might be determined, how market outcomes might be affected by certain actions. So whenever you have any kind of uncertainty, you're going to want to create as much certainty as possible via the introduction of probability into your analysis. So this is a big dimension to the sort of end game to all of this. Where if you were to analyze how economists are working in practice at central banks, at hedge funds, at other government agencies, financial institutions, etc. All the models that are being used there are going to have foundations of things that we see here, but they will also have a lot of probability included in them because you have to try to account for as much of the sort of chaos that you can in order to kind of rein it in to try to say, well, as much as we can do, we have done to give an idea of what could happen given what we know has happened and what we understand the current conditions to be. It's how we forecast the best possible. But again, the world is very uncertain ultimately. We are all driven by animal spirits, which is what John Maynard Keynes termed the animal side of us, that side that doesn't necessarily abide by logic. And so because of that, we can't be perfect in what we do, but we can try our best. And so part of that approach is to incorporate some probability into our analysis, and try to at least identify some of the best options available that could likely occur. So we'll just briefly talk about some issues related to the economics of information and how information is central to market interactions, but given the nature of market interactions that are adversarial, where you have consumers that want to pay the lowest possible and producers that want to charge the highest price possible, then in order for them to reach an understanding, even if they might not have the same information, like there have to be effective signals sent between them. So we'll talk about the two important properties of signals that make them effective. And then we'll start to talk about the rational consumer choice model in a very simple way. In the case of uncertainty, when a person is trying to choose the outcome that's going to make them the happiest, give them the highest amount of utility, but under a situation where maybe they don't know what could happen, maybe they have a couple of different options that could occur, and so under those conditions, they have to not maximize their utility, but maximize their expected utility, what they expect might happen and how they feel about that. So we will start to kind of look at the mechanics of that as far as the approach that we take today, and then we'll finish it off on Thursday. But before we do that, and then it's all kind of related, ultimately to insurance pricing. So once we establish our framework, I'll give the example of how the approach can be used to price insurance, which is a super big industry and very lucrative. Kind of boring ultimately if that's what you wind up doing, but you can make a lot of money in there. It's called actuarial work, kind of gauging risk and being able to price under risky circumstances. So I'll lightly touch upon like the approach that is taken there as related to the concepts that we establish in this chapter. All right, but let's talk about consumer surplus, unless somebody has a question about something that they'd like me to address in general before I get moving. All right, cool. So this, what is this? This is chapter 6. So I'll open up the homework for this today, if you want to just jump on it and get it done really quick. So you have the weekend to just focus on studying. And then the mini paper I won't have due till like the following Sunday night. So you'll be able to work through that next week if you choose to write a mini paper on this chapter. All right, consumer surplus. So again, like in a market, all the market participants have differing, well, at least on the consumption side, differing willingness to buy, willingness to pay, right? So you might be willing to pay one thing, whereas I'm willing to pay something else for the same thing, a slice of pizza. I'll pay $2. You're willing to pay $3, depending on how hungry you are, how much you prefer pizza, etc. So in a market, we all come together, and the demand curve essentially represents our willingness to pay along the spectrum of possible consumers that could be involved in the market. So this is just a very simple case where you have 1, 2, 3, 4, 5 people that are willing to buy. This is a used book. This is the price of the book. And so because there's only 5 people, we have like this step shaped demand curve, not the normal smooth shape, but it's just meant to highlight the nature of consumer surplus. So Alicia has a willingness to pay what we call her reservation price, the price where she would be indifferent between buying and not buying. It's just a cutoff for her. And so she's willing to pay up to $59. That's her reservation price. Brad is willing to pay up to $45, Claudia $35, and so on and so forth. So depending on what price is set in the market, there's going to be a net gain, a difference between what a person is willing to pay and what they have to pay. So the net gain is the individual consumer surplus, the net gain to an individual buyer from the purchase of a good. It's equal to the difference between the buyer's reservation price and the price paid. So again, suppose the campus bookstore makes used textbooks available at a price of $30, let's say. So the price is $30. That means Darren, whose willingness to pay is $25, is priced out of the market. So is Edwina, who is only willing to pay $10. Claudia, though, is willing to pay $35, which is above the $30. So is Brad. He's above the $30, and so is Alicia. So the difference between Alicia's willingness to pay and what she has to pay is $59 minus $30, which is $29. So that's her consumer surplus. Brad, $45, willingness to pay. $30 is what he has to pay. $15 is his consumer surplus. Claudia, she's willing to pay $35, has to pay $30. Her willingness to pay, her excess willingness to pay, her consumer surplus, how she benefits from the market is $5. Total consumer surplus is the sum of the individual consumer surpluses of all the buyers of a good in a market. In a figure, the total consumer surplus is the sum of the individual consumer surpluses. So it's 29 plus 15 plus 5, which equals 49 bucks in this case. It's the area below the step-shaped demand curve and above the price they are charging. In general, in economics, we don't differentiate between individual and total consumer surplus. We just call it consumer surplus. So whenever we're talking about either individuals or a total consumer surplus, the sum of all consumer surpluses in the market, we're just talking about consumer surplus, and it refers both to total and individual. So in the previous figure, we illustrate a general principle. The total consumer surplus generated by purchases of a good at a given price is equal to the area below the demand curve but above the price. So here's a normal smooth shaped demand curve representing the fact that there's a lot of consumers in this market. So as in the original example, consumer surplus is going to be equal to the area below the demand curve and above the price. And when we're dealing with a linear demand curve, then we're just dealing with the area of a triangle. And so to quantify how much consumer surplus is in the market, you just basically have to take the area of this triangle here. So the height is the difference between what's called the choke price, which is the price at which quantity demanded is equal to 0, and the equilibrium price, so that's our height, and the base is the quantity demanded at the price. 1/2 the base times the height is the area of a triangle, so that's how you can quantify a consumer surplus when demand is linear, which is the cases we consider in this course. Quick example, a typical consumer's demand for the Happy Beverage Company looks like that in the figure. So let's say they have to pay a price of $3. At $3, folks are willing to buy 2 units. So this is the amount of expenditures, which is also the revenue that the firm collects. And then you've got all of this area that represents the excess willingness to pay from all of these consumers that, again, are willing to pay more than the $3. And so the area below the demand curve, above that price, is the consumer surplus. So at a market price of $3, how much revenue will the firm earn and how much consumer surplus will the typical consumer enjoy? So how much revenue will this firm earn? $6, right? They're going to sell 2 units at $3. So expenditures equal revenue. Expenditure is just revenue from the point of view of consumers. So the amount of revenue is going to be equal to $6. So price times quantity is revenue. In this case, it's equal to $6. Revenue will play a big role in the next part of the course. We talked about revenue last time also, the relationship between elasticities and revenue. So make sure you understand that relationship. All right. The shape of the consumer surplus with a linear demand curve is a triangle. So what is the height of this triangle? It's 2, right? It's the difference between 5 and the price being paid. And what is the base of the triangle? 2 again. So base times the height times what? 1/2. 1/2 the base times the height, right? Area of the triangle. So that's going to get us our consumer surplus. So we have 0.5 times the base, which is 2, times the choke price minus the market price. So the choke price is the price at which quantity demand is equal to 0. It's also the vertical intercept of the inverse demand function. So 0.5 times 2 times 3 times 2, which equals $2. All right, so that's consumer surplus. All right, let's do a practice problem throwing in a bunch of stuff that we've covered. So monthly demand for 1-bedroom apartments can be described by the inverse demand function P equals 3,000 minus Q over 3, while supply, the inverse supply function, is equal to Q over 10. P is the monthly rent. So the question is, first, what is the equilibrium rent? So ideally, at this point, you all know how to solve for that. So we have a system of equations. We have 2 equations, 2 variables, price and quantity. So we'll use both equations to solve for the equilibrium price. So in this case, they're both set equal to price, so I just set them equal to each other, which is essentially like plugging one into the other. So here, essentially, we've got Q over 10 equals 3,000 minus Q over 3. I multiplied the whole thing by 30 here to get a common denominator for the entire problem, because this was over 3 and this was over 10. So multiplying this by 30 got me to 3Q. Multiplying this by 30 got me to 90,000. Multiplying this by 30 got me to negative 10Q. Now I'm going to combine my Q's. I'm going to add 10 to both sides. That gets me 13Q on the left equals 90,000. Divide both sides by 13 gets me the equilibrium amount of apartments transacted in this market to be 6923. And now I can use that to figure out any of my the amount of rent that's the equilibrium in this market from any of the two equations that I have. I chose my inverse supply function, plugged in my quantity in there, 6923. Divide that by 10 to get me a price of roughly $692. All right, so that's something you've seen before. You've done it, and ideally you are comfortable with that. What is the net benefit in this equilibrium for renters? What am I asking for here? What was that? Consumer surplus, right? That's what I'm asking for when I'm asking for net benefit. So I may not explicitly mention consumer surplus in a problem, but if I'm asking you for the net benefit or like, can you quantify the welfare to the consumers in this market? It's just about you basically reflecting your understanding of the concept of consumer surplus. What does it mean? It's not just something you calculate, it means something. It's actually a very powerful analytical tool. And can be very useful in business practices, which we'll talk about later in the semester. But yeah, in this case, we're looking at the net benefit. So we're looking at the consumer surplus for the market. So essentially, you're not given a graph here, but you have equations, so you can figure out what you need to by just kind of either visualizing it or just kind of knowing what it is you're looking for, right? So here is our inverse demand function there. We know consumer surplus is equal to 1/2 the choke price, the price at which quantity demand is equal to 0, minus the equilibrium price, times the equilibrium quantity. What is the choke price here? It's 3,000. It's the vertical intercept for our inverse demand function. But remember, if it's not an inverse demand function form, you've got to get into inverse demand function form, or you can just plug in quantity equals 0, and then figure out what the price is there, regardless of what form the equation is in. Anyway, there's our choke price. Equilibrium price we figured out to be 692, and we got the equilibrium quantity. It was like 62.23 or something. So there's consumer surplus, 1/2. The height of that triangle, which we're not seeing, but we know to be, again, the difference between the choke price and the equilibrium price, times the base of the triangle, which we know to be the equilibrium quantity. Plugging that into your calculator, making sure you get the order of operations correct. We get 1/2 2308 times 6293, which equals a fairly hefty consumer surplus in this market, nearly $8 million. So now why that's important to businesses, because if they can figure out what consumer surplus is, then they can figure out how to extract it from consumers. You see it like in certain strategies, like just subscription-based services. Like in the last few years, all the applications that everybody uses went from just being your standard buy the application for however long to like buy the subscription for a year, right? The Office tools, the Adobe software, all of them, like they figured out like we can actually charge this certain amount that we can quantify via the consumer surplus and then extract as much consumer surplus as possible, because we know there's excess willingness to pay in these markets. So let's try to get it. So that's what they do. They use consumer surplus to figure things like that out, like subscription-based service fees. Anyway, what is the elasticity of demand at this equilibrium? Is demand elastic or inelastic? All right, so what is the formula for elasticity that can help us solve this really quickly? Elasticity equals, we derived it last week. Well, that's your standard way to define elasticity, but what did we derive that then made it really easy to extract information from like the information we have? So there was a slope in there. Exactly, yes. It's equal to the slope of the demand function times the price over quantity, or 1 over the slope of the inverse demand function times price over quantity. Remember, the elasticity is equal to the percent change in quantity demanded over the percent change in price. The change in quantity over quantity times 100, the change in price over price times 100, the hundreds cancel out. Ratio divided by ratio equals the ratio times reciprocal of the bottom ratio, which we can move around to get to the slope of the demand function times the price over the quantity, or 1 over the slope of the inverse demand function. So what's 1 over the slope of the inverse demand function here? -3. The slope of the inverse demand function is -1/3. The reciprocal of that is -3, which is the slope of the demand function. So we're looking for the elasticity of demand at the equilibrium, right? So we have our price and we have our quantity as well. So we have everything we need to figure out the elasticity. So plugging that stuff in, we have -3 times price 692 over 6923 quantity. That's going to get us an elasticity of -0.3. So what can we say about this elasticity, the elasticity of demand at this equilibrium? It's inelastic, right? It's between 0 and 1 in absolute value. So if the price elasticity of demand is between 0 and 1 in absolute value, we say that demand is inelastic, right? It's not very responsive to price changes, not very sensitive to price changes. All right. What is the equilibrium quantity if the local government imposes an apartment tax of 5% on landlords? So think about these two equations here. How do we introduce, first of all, not how do we introduce this tax, but how do we introduce a tax on the supply side? So which one is...
On the supply side, to subtract 5 times quantity.
0.05, right? Times the price, right? 5% of the price. So just so remember, in order to like think through these problems, like you just have to think, first of all, the market is in equilibrium. If the market is in equilibrium, the producer is collecting P. And so if the government is now coming in saying we're going to take 5% of that, then that means we have to subtract 5% from that P. So that's going to be P minus 0.05 P. So that's how we introduce that tax there. If it was the consumers being taxed, then the consumer will pay the extra amount, right? So they're paying P. So then you would add that to their P. So it would be P plus 0.05 P. So here we got the supplier being taxed 5%. So P minus 0.05 P is how I incorporated that tax into the supply function. That's going to get me to 0.95p, divide both sides by 0.95. That gets me to my new taxed inverse supply function, P equals 0.105q. And now you just want to solve for the equilibrium quantity. So it's just your standard now approach of just like two equations, solve for P, solve for Q, and you're done. So the trick with the tax stuff is just figuring out how to incorporate it. So just make sure you have the logic down of that. Yeah. So I subtracted the 5%, so that was left with 0.95p, and then I divide both sides by 0.95. Because the supplier is collecting P, right, from the market, and then they have to give 5% of that to the government, right? Whereas with a consumer is paying P, and now they have to pay 5% more, right? So you would add. Yeah.
You said that some like industries use this to like figure out how much they can get as their buyer.
Yeah, the
Where do they
consumer.
get the data for this?
So they get the data from the market, like they maybe if they're whatever good that they're selling in the market, like they could look at how much of that good is being demanded at different prices in different areas. And then using statistical analysis, regression analysis, you can actually estimate a demand function. And then once you have that, then you can estimate consumer surplus, elasticities, everything from it. Yeah. Either their past performance or they hire economic consultants to do the analysis of markets, or maybe the markets analysis has already been done and it's just proprietary, they have to pay for it, etc. So you're talking about the fact that the market is currently over the inelastic range of demand. When it's over the inelastic range, if they raise the price, they will raise revenues, right? But if they keep raising the prices, they'll eventually get to the unit elastic that will maximize revenue, and then they'll get to the elastic portion of demand, which means that if they continue to raise prices, they'll actually decrease revenue. So if they, eventually they will get to zero. Yeah.
So when they get to zero, that's unit elastic.
No, unit elastic is when the elasticity is equal to 1. Yeah. Yeah. All right, so then here again, we're solving for the equilibrium quantity once the landlord has been imposed that 5% tax. So once we've incorporated the tax into our inverse supply function, if we now equate it with the inverse demand function and solve for our equilibrium quantity, just doing some math again, setting them equal to each other. And in this case, I multiplied the whole thing by 3, and now I combine my q's, add a q to both sides, and then divide both sides by 1.3158, and that gets me to the equilibrium quantity transacted now to be 6840. So we see that the equilibrium quantity has been decreased from 69.23 due to the tax. Any questions on this? All right, let's jump into chapter 6 then. The economics of information and choice under uncertainty. So just briefly, the first part just kind of like discusses the fact that, again, we are dealing with an adversarial relationship, and so signaling is important. And so what makes a credible signal? Well, there's 2 properties. We'll talk about them now. So the problems of communication between parties whose goals are potentially in conflict are fundamentally different from those involving parties with common goals. Obviously, someone has something to gain, someone has something to lose, so there is incentive there for information to be withheld. The seller sometimes has an incentive to overstate the quality of a product. The buyer often has an incentive to understate the amount that she is willing to pay for it. So signaling is a way of communication that conveys information. There's 2 important properties of signaling between potential adversaries, important for understanding how economic agents gather and interpret information. The first one is that the signal must be costly to fake. So the costly to fake principle says that for a signal to an adversary to be credible, it must be costly to fake. We'll talk about that more in a second. And the second one is the full disclosure principle, which says that individuals must disclose even unfavorable qualities about themselves, lest their silence be taken to mean that they have something even worse to hide. So those 2 properties are important in order for signals to be credible in a situation where you have an adversarial relationship. So let's look at a couple examples of each of these. So as far as the costly to fake principle, if we're thinking about like product quality assurance, firms that offer high quality need a means of communicating this fact to potential buyers in order to cover their extra costs, right? They also are competing against other sellers, right? So if they're willing to put in extra resources into creating a better quality product, then they need to be able to signal that effectively to consumers so that consumers are willing to buy from them versus somebody else. So, one simple solution is to build a reputation for delivering high quality, which is something that can be established in a variety of ways, one of them being through advertising. So a firm can demonstrate a stake in the future for any promises to be credible. So by firms investing money in advertising, they're essentially saying that they are willing to spend money to relay a signal which really ultimately has no value beyond that. Like advertising is a sunk cost. So a firm with significant sunk costs can establish credibility with consumers and establish a reputation of quality. Extensive advertising is a sunk cost. So if the firm is willing to do that, that means that they're in it for the long haul. If they're in it for the long haul, that means that whatever they're saying must be credible, because we know that if it's not, people will buy their stuff, realize it's crap, and nobody will buy from them again. So just the mere fact that they're willing to spend money on advertising reflects the fact that that they are sending a signal to consumers that is credible, and spending that kind of money on advertising is costly to fake. You can't fake that kind of thing. It's something that that folks are very clear about the nature of. Another market we can consider, of course, is labor markets. In labor markets, workers are selling their labor. So all of us that might be looking for jobs, we are the suppliers, and the on the demand side are the firms hiring, right? So the market is it's kind of a slightly different sort of theoretical animal, in the sense that you kind of have to put yourself in different shoes. But in that market especially, it's really important to be able to relay credible signals. So firms need a signal to identify employees that they can trust. The organizations folks join is sometimes a signal of their trustworthiness. So one example the book gives is that New York City couples advertise for nannies in Salt Lake City, Utah, because they've come to believe that folks raised in the Mormon faith tend to be more trustworthy on average than those raised in New York City. So they believe that is a credible signal of that sort of whatever set of qualities you need to be a responsible nanny. And obviously, being a Mormon is costly to fake. You're not going to be able to fake that really easily. You're going to have to put in a lot of work, and it's probably going to be very painful. So that's one sort of simple example. Another one, being the most relevant here to you guys, is of course a college degree. A college degree is a signal that's obviously costly to fake. You really couldn't fake it. Like, you write down on your resume or whatever, you have a college degree, and your employer will call the universities to verify these degrees. So college degrees are a very important signal of quality. So you should be proud of what you're doing here and try to make the most of it. But also, you need to understand why it is that the courses that you take are as rigorous as they are, and the expectations on you are as high as they are, because that signal needs to be credible. We need to be able to send the right signals to employers that you actually built up the kind of person that is valuable and is worth hiring beyond these walls. So to just get a bunch of people through the university and really have them just kind of slide by and not being challenged in the way that anybody else is challenged in any other program that is accredited, basically puts us in a situation where we're sending non-credible signals. We're making the signal of value that a college degree relays to not be costly to fake, to be easy to fake, because people can easily just get through an easy program and just be able to write on their resumes that they have a degree, and it ultimately be meaningless. So there's a lot of reasons why you're going through what you're going through here, and it's worth your time. And ultimately, that signal will be credible. And again, it is because it is costly to fake. Another quick example: conspicuous consumption as ability signaling. So conspicuous consumption is consumption of things that are of brand name, high quality, Mercedes, name brand clothing, etc. All these things are what we consider conspicuous consumption. And for important decisions involving people we do not know well, even weak signals of ability are often decisive. And if folks are conspicuously consuming, then that sometimes tends to reflect the fact that they have put in extra time in this world, and they have cultivated a more valuable person than otherwise. So consuming quality does signal high income, which is positively correlated with the ability to do anything that you're required to do in a competitive market. So dressing up for job interviews can be an effective signal for certain occupations, but there, of course, are exceptions. Like a great lawyer with a reputation for winning difficult cases can show up in an interview in shorts and a t-shirt and still get the job, because ultimately, if you are able to establish a clear-cut reputation of being top notch within your field, like silly things like this don't matter. But in situations where you are going into a situation where you don't have much of a reputation, much experience in whatever it is you're doing, simple signals like conspicuous consumption can provide that extra confidence that an employer needs to hire you, or whatever situation you might be in where a person's trying to consider you a viable candidate for something of importance. All right, so the other one is a full disclosure principle, basically saying that if you don't disclose everything, then it's easy to assume that you are hiding something. So even under the circumstances where it might not be the best situation to reveal, certain aspects of you or the quality of something maybe you're trying to sell, it's important to disclose that, because again, if it's not disclosed, then it's assumed that something is being hidden, something is being kept back. Quick example: product warranties. So whenever the two parties in transactions don't have the same amount of information, we say that there are information asymmetries. Information is not symmetric between the groups. Somebody has more information than somebody else. Information asymmetries help explain why producers of low quality products reveal their poor quality when offering limited warranties. So again, like, people are looking to buy things, and if you're looking for something relatively expensive, like an operating system or something of that sort, and they're offering you a limited warranty, that is relaying the signal to you that there's only a certain amount of time that the supplier is willing to protect you for, because the only thing you can assume under that circumstance is that there must be something wrong with the product in the long term. So firms that know they have a quality product have strong incentives to disclose the fact that they have a quality product. So that's why they'll offer extended warranties, which convey signals not just about the quality of the respective product, but of all remaining products as well. So good products without warranties would benefit from giving warranties, simply because of the fact that if you don't have them, people are going to assume that there's something wrong with what you're offering. So that's one example of how the full disclosure principle sort of helps to establish a credible signal. The other one is the lemons principle, dealing with the market for lemons in the used car market. That's always sort of been a conundrum of economics. Well, it was for a while before the paper I'm going to talk about right now, in which the question was like, why is it that new cars lose such a large fraction of their market value when they're driven off the lot? You may have experienced this before. Like, if you bought a new car, if you try to sell it like within a short amount of time after you purchased it, the market value dramatically drops because it immediately gets put into that category of a used car. So the Economic Naturalist 6.3 addresses this. So the question is, why do almost new used cars sell for less than brand new ones? So this was analyzed by this Berkeley economist, George Akerlof, in his paper, The Market for Lemons, which became the first clear statement of the full disclosure principle. He began with the assumption that all new cars are either good cars or they are lemons. Since the cars look alike, only the owner knows for sure which is the problem and which is not the problem. Since buyers cannot tell the types apart, new cars must sell for the same price regardless, and the price winds up being roughly a weighted average of the price of each type, weighted by their relative proportion with the distribution of new cars. So in some strange way, people do kind of indirectly make a calculation about, like, well, there is a likelihood that the car I get will be a lemon, given what I know, and so because of that, that is going to play a role in how I am going to value the car, my reservation wage. And so what they actually wind up willing to pay is a reflection of the weighted average of how many lemons they think might be in the pool of this type of new car versus some other type of new car. And so that's why all cars wind up being priced the same in the new car market. And again, the valuations, the prices that actually are wind up being transacted in those markets do reflect sort of like this weighted average of what people expect to get, given what they know about the likelihood of getting a lemon. The used car market is different since good cars are generally not put up for sale, right? So that's generally what we assume. If a car is being put up for sale in the used car market, generally you're going to assume that there's something wrong with the car. That's why people want to sell their cars. If they didn't want to, if there was something fine, if there was nothing wrong with the car, then they'd probably just keep the car. Yes, there's those other circumstances where people wind up, buying a new car and selling their old car, but oftentimes people are just selling their used car because they don't want any more for one reason or another. So prices tend to be low overall in used car markets, which reinforces the desire for good car owners not to sell. So because prices wind up being low, because everybody expects all cars to be lemons, then even those people that do want to sell their cars in the used car market that actually are fine can't do so because the prices are too low. So that's another reason why you're going to wind up getting like this, terrible sort of pool of cars. So Akerlof provided the insight that the mere fact that a car was for sale constituted important information about its quality. A new car driven off the lot and put up for sale will be priced with all the other used cars, since as a group, used cars are assumed to be of lower than average quality than those not offered for sale. So just the very fact that that a new car driven off the lot is being put up for sale must reflect the fact that there is something wrong with that car, and therefore the market price drops to the used car price, even though maybe it had just been purchased brand new, maybe like a week prior. Anyway, that's an economic naturalist essay that you could focus on if you'd like. And again, it highlights the nature of the full disclosure principle. If you're not disclosing the full quality of your product, then it's very likely that something is being hidden. And so in order for a signal to be credible, there must be full disclosure. And it must be costly to fake. All right, now let us move forward to choice under uncertainty. All right, so information can slip through the cracks, even when folks are being honest with each other. Something's maybe left out. Who knows? There may be some uncertainty overall in the market. There may be some weird weather condition that might affect the market outcome, and thus, there is going to always be uncertainty. So the section expands the consumer choice model from Chapter 3 to accommodate circumstances where information may be imperfect. In order to be able to account for imperfect information, we have to use probability, as I mentioned, and the concept of expected value. So sometimes choices are between two options that are equally risky. Sometimes choices are between a familiar option and an unfamiliar one. Economic decisions made under uncertainty are considered essentially gambles. So anytime a person is willing to engage in an economic decision and they don't know all the information, to some extent they are gambling, right? They are investing something into the transaction, the economic path that they're on, and sometimes they could lose. And so there's a probability they'll win, there's a probability they'll lose, and the weighted average of those gives them an idea of what may happen, and so that is ultimately what they have to base their decisions on, what they expect to happen, the expected value. So our intuitions about an attractive gamble versus an unattractive one carry over into economic decision making. So there is the sort of like the mechanical way that we can approach trying to rein in uncertainty, but then regardless of what we wind up expecting to happen, we have a feeling about that as well. So some of us are more willing to take on risks than others. Some people are huge risk takers. Other people are very risk averse. And then there's those people that are just like risk neutral. So we have to incorporate that into our analysis. Like, what is the attitude towards risk of the market participants beyond just like how do we account for the uncertainty? So let's say that we're considering three different gambles here. One is a fair. All three of them involve just flipping a coin, just a fair coin. It's equally balanced. It's got a head. It's got a tail. Whatever you flip it, there's an equal chance of getting heads, an equal chance of getting tails. The first option is you flip the coin, you get heads, you win $100. You hit tails, you lose 50 cents. So how many of you would be willing to take that gamble? Okay. Well, the majority of you, not everybody raise your hand. Some of you are just not willing to take any gambles at all, apparently. But like most of you see this as like a safe gamble. You feel good about this gamble. What if the coin was tossed and if you get heads, you win $200, twice as much. But if you hit tails, you actually wind up losing $100. So how many of you would take this gamble? All right, we got some risk takers in the house. Nice. And then finally, same situation. If you hit heads, you'll win 20 grand. But if you hit tails, you'll lose 10 grand. How many of you would take this gamble? All right, we got some serious risk takers in the house. But the number did decrease as the riskiness of the gamble increased, which reflects the fact that you have attitude towards risk. Different people feel differently about one gamble versus another. And so because of that, you'll have different market outcomes due to that attitude. And so we need a means of incorporating that into our analysis. So in general, again, most would take the first gamble, as we saw here. The second one's a little risky, but those that like to gamble will take it. And then most people would refuse the third, even though its payoffs are in the exact same proportion as in the second. So most people, as we saw, would not take the third. There are a few very risk-taking people, which, hey, good for you. I hope things work out for you guys. All right, so the theory of choice under uncertainty attempts to rationalize this behavior. One important property of a gamble that we'll consider first is its expected value. What can we expect to happen given what we know about the gamble? So the expected value is the sum of all possible outcomes weighted by their respective probabilities of occurring. So the probability of a fair coin toss resulting in heads half the time. The probability of a fair coin toss resulting in heads is 1/2, right? There's 1 out of 2 possible outcomes, and that's what you're going to get. For heads, you're going to get either heads or no heads, so that's going to be the probability of getting heads. It's going to be 1 out of 2 possible options. So again, this can be interpreted as saying that if a coin was tossed a large number of times, let's say an infinite number of times, then half the time the coin would actually wind up being heads. And the other half, it would wind up being tails. So it's a property that we get from what's called the law of large numbers, which we'll talk about on Thursday. Anyway, so mathematically, to establish the expected value of something, again, it is the weighted average of all possible outcomes weighted by their respective probabilities of occurring. So we've got probability of getting heads is 1/2, and you're going to win $100. Plus the probability of getting tails, which is 1/2, times the outcome of that, which is, in this case, lose 50 cents. So we'll have that negative 0.5 there. So again, those are the 2 possible outcomes weighted by their respective probabilities of occurring, meaning that they are being multiplied by the probability of occurring. So if you plug all this stuff into your calculator, we wind up with an expected value of $49.75. So the first gamble has a positive expected value, fairly sizable, $49.75. Expected value for the second option, again, 1/2 probability of getting heads means you get $200. So 1/2 weights the outcome of $200, 200 times the 1/2, plus the 1/2 probability of losing, which carries with it an outcome of losing $1,000. So that's going to, $100. So that's going to be a negative $100 there. So plugging in that stuff into your calculator will get you an expected value. In this case, the expected value will be $50. So the expected value is going to be a little bit higher for the second option than the first option. So we can see that the expected value doesn't consider at all attitude towards risk, because if you were simply to go off of whether you'd be willing to take a gamble or not based on the expected value, then most of you would have chosen the second option versus the first one, yeah. So
Like if, like, let's say it's just one time, you know, you use these drinks, but then you did it, you know, like 10, 20 times, you probably have a positive.
that's what the expected value is telling you, right? Yeah, exactly. Like the expected value is telling you that, like given the probabilities that exist and the possible outcomes, yeah, over time, like you should expect that kind of outcome. Like in this case, a positive outcome, right? And then on the third one, again, 1/2 times the probability, well, one half probability of getting heads, weighting the outcome, which is $20,000, plus 1/2 the probability of getting tails, times the outcome, which is equal to negative 10,000. And so in that case, you wind up with $5,000. So 5,000 is the expected value there. Highest expected value of our three options, and yet the one that people chose the least. So a gamble is more attractive if it has a positive expected value, but it clearly does not imply that a gamble is going to be attractive in general. In addition to expected value, how people feel about a gamble plays a big role in whether or not a person will accept a gamble. The gambles thus far have only had two outcomes, but in general, a gamble can have however many outcomes it's going to have. So under those circumstances, obviously, you would wind up with just more terms, and they would be weighted by their respective probabilities, and all probabilities for a set of possible outcomes in a situation will sum to 1, right? Something will happen. Even if one of the things that could happen is nothing, that one will have a probability of 0, right? But something's going to happen, and so in that set of probable outcomes, all the probabilities have to add up to 1. So if you, let's say, only have two outcomes that are told to you and their respective probabilities, you can add those together, subtract from 1 to figure out what the probability of the third one would be. But in general, let's say you have 3 possible outcomes, then you would have 3 different probabilities. Let's say each one is equally likely, so they each have 1/3 probability of existing, so of happening, and therefore that would weight each possible outcome, x1, x2, x3, which would be some payoff, whether positive or negative, and that would give us an expected value. And of course, you go further than that for outcomes that maybe have an infinite amount of possible outcomes, and there's a way to deal with that case as well. All right, so let's do a quick practice problem. Expected payoff, scalping a concert ticket. Imagine you want to buy a ticket to a sold-out concert. Your only hope of seeing the concert is to buy a ticket from a scalper. There's a 40% chance that the ticket you buy will be counterfeit. If going to the concert gives you $200 worth of pleasure, which we'll call the payoff, and the price for concert tickets is $175, what is your expected payoff if you buy a ticket from a scalper? All right, so we're going to set up an expected value here. So what is the probability of you buying the ticket and it not being counterfeit? 60%, right? Okay, good. So our expected payoff here, there's a 40% chance that you'll buy the ticket and it will be counterfeit, right? So what's the payoff going to be there? Negative 175, right? You paid the 175, which is a loss. And then what's going to be the other term here? 0.6 times 200, right? You pay for the times 200 worth of pleasure, but something else is missing there. That's another version, but still missing something that was already mentioned. Right, exactly, right. There's a 0.6 probability that you will pay for the ticket and you'll actually wind up getting a legit ticket and being able to go to the concert and enjoy the concert. But you do have to pay $175 for that. So that's 0.6 times the 200 minus the 175 there. So that's going to be the expected value, the expected payoff of this gamble, essentially, which is, again, you're buying a ticket from a scalper. You don't know if it's a legit ticket or not. Suppose you find out that you can buy legitimate tickets from an agency for $225. What variable would have to change in order for you to pay $225 for a ticket? What measured in what? Exactly. Measured in utility, right? Measured in pleasure, exactly. So your own sort of valuation of the ticket would have to meet the cost of the ticket, right? So it would have to go up by, in this case, $25, right?
What about the percent probability
If the percent probability of it being counterfeit decreased, well, you still wouldn't be willing to pay for the ticket though if it's $225. Oh, you mean avoiding?
percent goes down like 10.
Well, it's going to depend on how you feel about risk, right? Because you're going to get a different expected value, but the question is like, how do you feel about taking the gamble, which we haven't addressed yet. This is just about the mechanics of figuring out expected value. Anyway, so the payoff would need to increase by $25 in this case. All right, so now let us start to take us down the path of incorporating uncertainty into utility via what's called the von Neumann-Morgenstern expected utility model, which gives us insights about how a person might choose an option given how they feel, and also how we can incorporate those feelings into the model via just how we specify the utility function. So the formal economic theory of choice between uncertain alternatives was advanced by John von Neumann, a distinguished mathematician at the Institute for Advanced Study, and Oscar Morgenstern, a Princeton economist. The central premise is that people choose the option with the highest expected utility. So they don't choose the option with the highest expected value. They choose the option with the highest expected utility. Expected utility is the expected utility. The expected utility of a gamble is the expected value of utility weighted over all possible outcomes. And so we need to look at all possible outcomes. We need to figure out how people feel about them by plugging those values into a utility function and then weighting those by the probability of each outcome occurring to get the expected utility. So again, going back to our first gamble, a fair coin is tossed. Heads gets us $100, tails loses 50 cents, let's say. If a consumer had a starting wealth, let's say, of $1,000 and accepted the gamble and won, the outcome would yield a wealth of $1,100. The consumer's utility would thus be a function of their overall wealth now being $1,100. So if he lost, in this case, the wealth would go down from $1,000 by 50 cents to $999.50, and the consumer would feel U of $999.50. Like that. That's how they would feel about that amount of wealth as a result of losing. So generally, if a consumer has an initial wealth level of M naught, so again, that's going to represent income. We're assuming that every consumer has some sort of wealth. Then the expected utility of accepting gamble 1 is going to equal 1/2 the probability of getting heads times how you feel about your net wealth post the gamble. So your initial wealth plus the $100 plus 1/2 times the utility from 1/2 being the probability of losing, which comes with a 50-cent loss, times the way you would feel about that, the utility of your overall wealth net of your losses. So the utility of your initial income and your wealth minus that 50 cents. So that's how you calculate expected utility. If she rejects the gamble, she would get the utility from her initial wealth. So she would just feel however she feels about the amount of utility she already has, which is U of M naught. All right, so faced with the choice, the von Neumann-Morgenstern expected utility criterion tells you to accept the gamble if and only if the expected utility of the gamble is greater than the utility of your initial wealth. So that's the decision rule under this framework, that a consumer will choose a gamble if their expected utility is greater than the utility of their initial wealth. Example, suppose Smith's utility function is given by the square root of M, right? So that's the relationship between how the consumer feels and the amount of wealth they have. We talked about utility functions in 2 chapters ago. We looked at the relationship between that hypothetical person, Casey, and the amount of clams she ate. So it was just a relationship between how she felt, and one good, right, which we could represent with one utility function, which was curved. You had utility on the y-axis and amount of the good on the x-axis. And as she consumed more, her utility increased, but at a diminishing rate, right? She had diminishing marginal utility. Each additional unit gave her less utility, utils, pleasure, happiness, satisfaction than the prior one. And so by specifying this function here, we get that same relationship. A root function has that same shape that has diminishing marginal return. So what this utility function is telling us that the consumer has diminishing marginal utility with respect to his wealth. And remember, the utility function got more complicated when we added more goods to the consumption bundle. Became three-dimensional when the consumption bundles were made up of 2 goods, and then that's what allowed us to, develop the indifference curve framework, which represented all the preferences of the consumer. Make sure you understand all of that stuff. All right, so if Smith has an initial wealth of $10,000, which of the 3 gambles has the highest expected utility? So let's just go through each of them individually. So we have the expected utility of the first one, half probability of getting heads. That means they would win $100. They have $10,000 of initial wealth, so we add that to it, and then we plug it into the utility function to get the utility from winning. Plus 1/2 the probability of losing means he loses 50 cents, so we plug the 10,000 minus 50 cents into the utility function to get the amount of utility that he would get from the loss. So the utilities gained from each outcome weighted by the respective probabilities of occurring the expected utility. In this case, it would be 100.248. Second one, again, plug in 1/2 probability of winning, add 200 to the initial wealth of 10,000. So how much utility they gain from that win, that adds to how much they feel already about their initial wealth, plus 1/2 the probability of losing, 100 minus the 10,000. So the utility from $9,900 gets us an expected utility for the second gamble, in this case to be 100.247. We know that utility is just a ranking system, and so even though they're off by just 1,000th of a point, it doesn't matter. What matters is that this number is bigger than this number. So just the fact that this number is bigger than this number means that this gamble is preferred to this one. Remember, utility is ordinal, not a cardinal measure. The numbers themselves don't mean anything. They mean something relative to each other. And then the expected utility of the third gamble, again, plugging in 1/2 probability of winning, adding 20,000 to 10,000 gets us to 30,000, plus 1/2 probability of losing, so subtract 10,000, so that's basically the utility of 0, of square root of 0, which is 0. And so in this case, we have an expected utility of 86.803. So we've used this utility function to represent how a consumer might feel about risk, and we see that based on that, they would wind up choosing the first option, which is what a lot of you chose. So this type of specification did capture that attitude towards risk. So diminishing marginal utility in the utility function will capture that, what we call risk aversion, which I'll talk about more on Thursday. So gamble 1 is the most attractive. So the question is, will this person take gamble 1? Well, based on the von Neumann-Morgenstern expected utility criterion, they would take it only if their expected utility is greater than the utility of their existing wealth, right? So we have to figure out what is the utility of the existing wealth. So again, we plug in the 10,000 into the utility function, and that's going to get us 100 utils. So would this consumer choose this option? Yes, right? Based on the von Neumann-Morgenstern expected utility criterion, the expected utility is greater than the utility of the existing wealth, and therefore the consumer would choose this option. Is there a question?
It's just more of like a question about like the realistic implication there. I don't understand how so similar when like a 200 times chance of losing more money in the second one.
It's because of the utility function, like because you have the diminishing marginal utility, and so even though you have a big differential, the extra utility you gain from it is not that much greater. You get it?
This example, you use the decimals, unlike when you talk about the consumer surplus. So for this would be always
It doesn't. To me, it doesn't really matter. I think standard is just a couple of decimal places. Like what I'm looking for is that you understand what you're doing. You know, like if you're off a bit because you're rounding 2 places versus 3 or whatever, that's not going to make any difference to me at all. So that's not something you should worry about.
You got a different number for the last one. You're at 86.603.
86.603. Okay, I'll change it later. It doesn't make a difference, but thank you. All right, so yeah, 100.248 is greater than 100, and therefore this consumer would choose the gamble. All right, so the key inside the theory is that the expected values of the outcomes of a set of alternatives indexed by I need not have the same ranking as the expected utilities of alternatives. So again, how people feel about things will differ than what they know about what's likely to happen. So the interaction of the two is what makes a difference, and therefore when we are incorporating uncertainty into our analysis of markets, we have to incorporate also attitude towards risk, which we'll talk more about on Thursday. Have a great couple of days, folks. I'll see you on Thursday.